Hello Algebra 2 students. This video will be doing a Regent review of Unit 9, Trigonometry. I recommend watching the full overview of Trig if you feel you really need a deeper understanding of Trig. But this will just cover, every standard that the Regent could test you for within Unit 9. Which diagram below shows an angle rotation of 1 radian? So we know to convert from radian to degrees. Typically radians, have pi in it, and you want to get rid of pi. So you're going to be multiplying by something with pi in the denominator. And if you memorize that formula, or if you look at the Regent reference sheet, it's 180 over pi. So you're multiplying 1 radian by 180 degree over pi radians, which you don't really have to, conceptualize it so much more than that. But we're doing 1 times 180 over pi, which is just 180 over pi. So in my calculator, I'm going to do 180 divided by pi, which is 57.2957791 degree. So we know that this is 90 degrees, so it's not 2. We know that this is 180 degrees, so it's not 3. This is 360 degrees, so it's not 4. And 57 degrees is in between 0 and 90. So it is, in fact, 1. Okay. For this question, it says the terminal side of theta, an angle in standard position, intersects the unit circle at P, which is the point negative 1/3, negative radical 8 over 3. What is the value of secant theta? So I always recommend drawing it out. So draw out negative 1/3, negative 8/3. That would be in quadrant 3, because it's negative, negative. Make a right triangle. And it says that this point is negative 1/3. So this length here is 1/3. This height here would be your y value, so it's radical 8 over 3. And it's on a unit circle. So the unit circle has a radius of 1, right? It's 1 unit. So secant, we know that secant theta is 1 over cosine. If it was cosecant, that would be 1 over sine. If it was cotangent, 1 over tangent. And you could find cosine and do 1 over cosine, or do the reciprocal of cosine, right? Or you know that cosine is adjacent over hypotenuse, right? So TOA, adjacent over hypotenuse. So if it's the reciprocal of that, it would just be hypotenuse over adjacent. So your hypotenuse is 1, and your adjacent side is 1/3. So 1 over 1/3, you do keep change flip, 1 times 3 over 1, which is 3. Now we are not done. Remember, all students take calculus. In quadrant 3, only tangent and its reciprocal function, cotangent, is positive. So cosine, or secant, the reciprocal function of cosine, would be negative. So it would be negative 3. Okay. Using this unit circle below, explain why cosecant of theta is equal to 1 over y. So we know on the unit circle that your sine is cosine, your y is x, right? So cosine theta, sine theta. You also know that the radius is 1, so you could figure out why that is. So if you wanted to show that, right? This length would be x, this height would be y, and then if we wanted to find sine, right? Sine of, let's call this theta r because it's a reference angle. Sine of theta sub r would be your opposite over your hypotenuse. So it would be opposite would be y over 1. For cosine, that would be your adjacent x over hypotenuse 1. So x over 1 would be x. So you just prove that cosine is x, sine is y, right? If I wanted to show that work, you don't have to go this into depth, but sine of, let's say, theta r would equal y over 1, which just equals y. Cosine would be x over 1, which is x, which proves cosine sine theta. Cosecant theta equals 1 over sine. And we just said that sine is y, so you could just replace that. So that indicates that cosecant theta equals 1 over y. Again, you don't have to go so in depth. You just put anything that you could, kind of follow, right? You know that cosecant is 1 over sine. Sine is your y value, and that could be your explanation, right? Okay. Natalia's teacher has given her the following information on angle theta. Explain how Natalia can determine if the value of tangent theta is positive or negative. So, I always recommend drawing it out first. If you don't know radians, convert to degrees, but we know that pi is just 180, 2 pi is 360, and we're looking in between those two. So, if theta is in between those two, that means that we have limited options. We're not looking at quadrant 1. We're not looking at quadrant 2. So, we have all students take calculus. Cosine is positive here. So, that means it must be in quadrant 4, not quadrant 3. And then tangent in quadrant 4, only cosine is positive, so tangent would be negative. So we have our answer. So let's begin. State every reason that we just said. Pi is less than theta, which is less than 2 pi, implies quadrant 3 or quadrant 4. Cosine theta equals radical 3 over 4 is positive, which indicates quadrant 4, right? It could indicate quadrant 1, but quadrant 1 we already crossed out. Tangent theta in quadrant 4 is negative. And that's our explanation. Another thing you could have done, you could have actually solved for tangent. Create a right triangle. This would be your adjacent side. This would be your hypotenuse. And then solve for the opposite side. And then you would do opposite over adjacent. And then do all students take calculus. And you'll get that it's negative. Okay. Which diagram represents an angle alpha measuring 13 pi over 20 radians drawn in standard position? So first, I don't even know what 13 pi over 20 radians is, right? Let's convert it to degrees. So to convert to degrees, you would multiply by 180 over pi. This is on your Regent reference sheet. Pi cancels out. 180 divided by 20 would be 9. 9 times 13 is 117. So 117 degrees would be in quadrant 2. And it looks like it's the same for all... Oh, wait, nope. It's not the same for all of these. 117 degrees is positive, right? So if it's positive, it's not going clockwise. So we could already cross out 2. If it's positive, we go counterclockwise. So all of these alphas are drawn correctly. They're all the same. Now, for the reference angle, they're calling the reference angle theta. A reference angle is the angle, we could draw it. A reference angle is the positive acute angle that is in between your terminal ray and your x-axis. So we just said that this is alpha. That's what we have so far. Your reference angle, theta, is going to be this. So the only one that matches that is 4. It's not created by that in the y-axis, and it's not, this is just alpha that they drew twice. If we wanted to solve for the reference angle, let's take it one step further. You know that the bigger angle here would be 180, so you would take 180 and subtract 117, and you get 63. So your theta is actually 63 degrees, right? But that's just taking it a step further. You didn't have to do that. Determining trig functions. Cosine theta equals 7 over 25, where theta is an angle in standard position, terminating in quadrant 4. It gives you the identity. What is the value of tangent? So you could use the identity, or you could draw out your right triangle, right? This is adjacent over hypotenuse because it's SOHCAHTOA. And then you'd solve for your opposite using Pythagorean's theorem, and that, which essentially is what you're doing here. You're using Pythagorean's identity. And then you would be doing opposite over adjacent, and all students take calculus to find the sine. But since they gave us the identity, let's use it. Sine squared theta equals cosine squared. Cosine is 7 over 25. So we're going to subtract that on both sides. So sine squared theta equals 1 minus 7 over 25 squared. You get 576 over 625. Take the square root of both sides. So sine of theta equals 24 over 25. So then, this is in quadrant 4. All students take calculus. Cosine is positive. Oh, we're using the identity. So tangent, tangent theta is just sine over cosine. So sine we said was, so using all students take calculus, you know that sine is going to be negative in quadrant 4. Sine is negative 24 over 25. Cosine is 7 over 25. Keep change flip. So negative 24 over 25 times 25 over 7. 25 cancels out. You get negative 24 over 7. Which makes sense because only cosine's positive. So tangent has to be negative. Negative 24 over 7 is your answer. Okay. If cosine A is radical 5 over 3 and tangent is less than 0, what is the value of sine A? So first, let's see why they're giving us that information. Cosine of A is, so we have all students take calculus. Cosine's positive, so it could only be quadrant 4 or quadrant 1, right? All trig functions are positive or just cosine's positive. So it's not quadrant 2 and not quadrant 3. tangent is less than 0, meaning that tangent's negative. So all functions can't be positive. It has to be quadrant 4. Now we could draw out our right triangle. And in SOHCAHTOA, right? For cosine, this will be our adjacent, this will be our hypotenuse. So your hypotenuse is is 3, and your adjacent is radical 5. For sine, that's it's opposite over hypotenuse. So we're going to have to solve for that missing side. 3 squared plus x radical 5 squared plus x squared equals 3 squared. Subtract that radical 5 squared, which is just 5, right? So subtract that 5. You have x squared equals 3 squared is 9, 9 minus 5 is 4, square root of x squared on both, square root of both sides. X equals 2. So now sine is opposite over hypotenuse, so 2 over 3. So sine of A equals 2 over 3. Remember, all students take calculus. Only cosine would be positive, so you have to make it negative. Right? You know when we're using a right triangle, right? You're using the reference angle. You're not actually using the entire angle of that trig function. So that's why you have to check for all students take calculus. Because technically the math we're doing is for quadrant 1, and then all students take calculus will tell you whether it would have been positive or negative. Okay, this identity, we know the identity is sine squared of theta plus cosine squared of theta equals 1. Notice theta and theta, it has to be the same angle. So if this angle is 32, then this angle has to be 32 in order for it to work. Okay. For this question, modeling trig functions, we have the midline. Remember, y equals a. Oh, they actually gave it. Well, let's rewrite it because there's more. Y equals a times cosine of b times x minus c plus d. A is your amplitude. C is your phase shift. D is your midline. B indirectly gives you the period by using the formula 2 pi over b. Okay, so your midline, D, is at 3, so it's plus 3. Your amplitude is the distance from your midline to your peak or your midline to your minimum. That distance is 2. Okay. And then there was no phase shift. It's starting at 0. So your C is just 0. So we have B, X. We want to solve for B now. B indirectly gives you period, right? So look at this. Starting at 0, when would the pattern restart? Going around, going around. Oh, it would restart right there. So from 0, it goes all the way to pi over 3. So your period equals pi over 3. So remember, period equals 2 pi over b. If your period is pi over 3, what I recommend doing to make it easier on yourself, take the reciprocal of both sides. And then you could just multiply by 2 pi on both sides. Pi cancels out, 2 times 3 is 6. So A is 2, B is 6, and C is 3. Answer is 1. Okay. The depth of water in a marker 20 feet from the shore in a bay is depicted in the graph below. If the depth D is measured in feet and time, T is measured in hours since midnight. What is an equation for the depth of the water at the marker? So first, this is going by what? 2's? So 2, 4, 6, 8, 10, 12, 14. So your midline is at 9. So your midline is at 9. So we could cross out 2. Your amplitude, so 14 to 9 would be 5, right? So your amplitude would be 5, so that checks out. Your period is going to be the same because you have the same B, right? So now we have to look at if this is a sine or a cosine function without shifting it, right? So remember, sine looks like this, starting at the midline. Cosine looks like this, starting from the maximum. If we were to make it negative, right? If we were to flip it, it would look like this, still starting at the midline. And for cosine, it would be starting from the minimum. So this very clearly is a sine function because it starts at the midline. So your answer would be 4. The Ferris wheel at a landmark Navy Pier in Chicago takes 7 minutes to make one full rotation. So one full rotation, that's one full cycle. Your period is in 7 minutes. The height h in feet above the ground of one of the 6-person cars can be modeled by this function, where t is in time, in minutes. Using h of t for one full rotation, this car's minimum height in feet is, so picture this, you're going to have a midline, you're going to have an amplitude. If we're trying to find the minimum height, you would take the midline and subtract the amplitude. So the midline we know is 80 because it's in that D spot. The minimum, what you're going to do, you're going to subtract the amplitude. So 80 minus 70, you get 10. What if we took it a step further and found the maximum, right? If we wanted to find the maximum, you take the midline and you would add the amplitude. So you'd get 150. Okay? So that's how you find the y values of your trig functions, right? That's how you find the max, the minimum, and the midline. If you wanted to find where it lands, like what x values they're at, you could just find the period, and then you find the sketch point. And in this case, you have a phase shift, so you'd start from the phase shift, and then start adding the sketch points. I'm sure we're going to do that here. So this is the last question, graphing trig functions. First, let's find the y values. The midline is going to be 2. Your minimum, you take the midline and you subtract the amplitude. So 2 minus 3. Your maximum, you're going to add the amplitude to the midline. So we have 5, 2, and we have -1. So we have our min, our midline, and our maximum. Now, let's find the period. We know period is 2 pi over b. So your b is 2 in this case. So your period is pi. Your sketch point, we want to split our trig functions into 5 intervals. So you're going to divide 4 intervals, 5 points. So you're going to do period divided by 4, and that's pi over 4. You start from the phase shift. Nothing is attached to x in parentheses, so that's essentially saying x minus 0 or x plus 0. So you start at the phase shift of 0. So start at 0, you're going to add the sketch point. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So you have, let's simplify these, 0 pi over 4, pi over 2, 3 pi over 4, pi. It wants you to go to 2 pi. So we're actually going to double this up. So we're going to be showing 2 full rotations, 2 full periods. So we said the heights are going to be -1, 2, and 3. And 5. -1, 2, and 5. This is a sine function, so you're going to start at the midline. Let's start showing these points. So we have 1, 2, 3, 4, 1, 2, 3, 4. So we're going to have enough space to space it out by 2's. Label your axes, so pi over 4, pi over 2, 3 pi over 4, pi. If we were to go further, right, it's going to be 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, 8 pi over 4 is just 2 pi. Okay, and then to graph this, start at the midline. This is positive, so we're going to go up. It's just your basic sign, right? If it was negative, you'd go down. So we're going to go up to the maximum, down to the midline, down to the minimum, up to the midline. That right there is one full cycle, but it wants us to show over domain 0 to 2 pi. So let's do another. You're going to go basically repeat everything that we just did. So up, down, down, up. And that would be t of x. Just to talk about one thing further that it's not really asking for. You know the period of a basic trig function, so a basic sinusoidal function, sine and cosine, is going to be 2 pi, right? So how many periods, how many full cycles did you see within 2 pi? You saw 2, right? So this is actually showing you the frequency. Their frequency here would be 2 out of 2 pi, which is 1 out of pi. But if you ever are asked frequency, you know it's just the reciprocal of your period. So 1 out of pi. But that's what frequency means. It's how many times did it occur. How frequent did this cycle occur? And it occurred 2 out of the normal 2 pi. Okay, thank you.